Here we are back at solving equations, but today we're going to look at something slightly different. We're going to look at equations that have variables on both sides of the equal to sign. So we're going to start by looking to see if there's anything to simplify. I don't see any parentheses or like terms on one side, so I'm now going to collect my variables to one side using my inverse operations and my subtraction property of equality. That will leave me with 3x plus 2 equals 14. This is now converted to a two-step equation. Let's subtract 2. Lastly, we'll divide by 3. And here is an example of an equation with variables on both sides that has just one solution. We'll do a check. 5 times 4 is 20. 20 plus 2 is 22. 2 times 4 is 8, and 8 plus 14 is 22, and it checks. On to problem 2. Once again, nothing to simplify, no groupings, no like terms on one side, but there are variables on both. So step 1 will be to collect variables to one side. And we'll do that by subtracting on both sides. That leaves me with 3x plus 2 equals negative 10. I'll now subtract 2 on both sides, and I have 3x is equal to negative 12. Remember to add the opposite, and we divide. This time, once again, I have just one solution. X is equal to a negative 4. If you were to substitute that back in, once again, 7 times negative 4 is negative 28 plus 2. And then we have negative 4 times 4, which is negative 16, minus 10, both sides, negative 26. Now let's look at some equations that have grouping symbols. If we see parentheses, we'll start by distributing. We'll distribute the 2, and we get 10x minus 2 on the left. We'll distribute this 3 and get 3x plus 33 on the right. Now you look and you see that once you have simplified, you have variables on both sides, it's time to collect them to one side. That's the very next step in order to isolate your variable. We'll now add 2 to both sides. Again, multi-steps. And lastly, divide by 7, and your solution is x is equal to 5. From time to time, I will ask you to actually do the check. But today, I'm just moving forward with these problems. Grouping symbols once again, let's distribute on both sides. I now have 8y plus 4 and 2y minus 26. Variables on both sides, let's subtract that 2y. Leaves me with 6x plus 4 equals a negative 26. Using the subtraction property of equality, let's inverse and subtract 4 on both sides. Divide, and x is equal to negative 5. So what we've done with our two-step and multi-step, we're now doing with variables on both sides. It just tells us to collect the variables to one side. Now comes the part that's slightly different. An equation is true for when an equation is true for every possible value, it's an identity. For example, x plus 1 equals x plus 1. It's the same on both sides, so that's an identity, which means that I can substitute any value of x. So x is equal to all real numbers. Or some people might just call it infinite solutions. Because an identity says any value of x, I could pick 5. 5 plus 1 equals 5 plus 1. True statement. 6 is equal to 6. Negative 6 or negative 6. Negative 5 equals negative 5. Once again, an identity. On the other hand, an equation has no solution if there's no value of the variable that will ever make the equation true. If I have x plus 1 equals x plus 2, okay, slight error here, this should be an x. We're going to see that there is never a value for x that will make that true. I could put in x is equal to 2. Well, 2 plus 1 is 3, and 2 plus 2 is 4. So there's no value for x that will ever make that statement true. So that would be a no solution equation. Let's test a couple of them out. Before you start moving anything, you look to see if you can simplify. Nothing to simplify on the left, but there is a grouping symbol on the right. I now have 10x plus 12. You might stop there and say, wait, this is an identity. But if I collected my variables on one side, you're going to see that this does cancel out, and I get 12 is equal to 12, which is an identity. And if it's an identity, that means that I can choose any value of x that will make that statement true. On to the next problem. I look at this problem and I see there's nothing to simplify on the left, but on the right I have some like terms. As I combine the like terms, I'm going to have 9x plus 5. My next step tells me to collect my variables on one side, so I'm going to subtract 9x on both sides, and they cancel out. That leaves me with negative 4 is equal to 5, which is a false statement, so this is an equation that has no solution. There is no value of x that will ever make that a true statement. So see, today we had an opportunity to do some multi-step equations that involve variables on both sides, and we'll explore a few more in class. See you then.